All right, we're now on to Chapter 7 in Fire in California's Ecosystems. This chapter is all about fire and physical environment interaction. So how fire influences soil, water, and air. And we're going to do this video the same way we've done all the past lectures, where I'll show a 1-minute video where I basically summarize the entire chapter in 1 minute. It might not make all that much sense when you first hear it, but then we're going to go through it line by line and really dive into this chapter. So here's that video now. Water, earth, fire, air. Long ago, the four nations lived together in harmony. Then everything changed when the Fire Nation attacked. While fire's interactions with the physical environment may not be as exciting as the show Avatar, wildfire can have significant impacts on soil, water, and air. The effects on soil can be either beneficial or detrimental. The burning away of vegetation and organic matter can enhance nutrient availability, but it can also lead to erosion as hillsides are no longer held in place. Erosion can also be accelerated after fires because the soil becomes more water repellent. With less water infiltration, you end up with more overland flow. This can impact water quantity and quality downstream as both flow rates and sedimentation increase. And even if you don't live in California, you've probably seen the impact fire can have on air quality as smoke is transported downwind. This can affect the health and well-being of both human and biological communities. All right, so here's how the video starts out. Water, earth, fire, air. Long ago, the four nations lived together in harmony. Then everything changed when the Fire Nation attacked. While fire's interactions with the physical environment may not be as exciting as the show Avatar, wildfire can have significant impacts on soil, water, and air. So I threw that first line in there just in case there's any Avatar fans out there, but I thought it was perfect for this chapter because it's all about fire's interactions with earth, water, and air. I'd say the difference, though, is that in the show it's all about how the Fire Nation attacked, whereas fire isn't actually always detrimental to soil, water, and air. Sometimes it can actually be beneficial. But before we get into the weeds, no pun intended, I should probably just define what soil, water, and air are that we're going to be talking about. So soil, that's the weathering of bedrock over time. It mixes with organic material, and soil is very important because it's basically the foundation of the entire terrestrial ecosystem. Without soil, you're not going to have plants. Without plants, you're probably not going to have animals. So soil is very important. So how fire interacts and changes soils is also going to be important. And then with water, think the water cycle, where you get precipitation in the form of rain and snow, and then that finds its way into the streams, the groundwater, into our plants, into lakes, and then what happens after that? You get evaporation from the streams and the lakes. You also get transpiration, which is water coming out of the plants, and then that goes up into the air, it condenses, forms clouds, and then you get precipitation. So it's that cycle, which does get impacted by fire, and we'll talk about that. But then finally, air. The main thing we'll be discussing, at least for this chapter, is the impact that fire and in particular smoke has on air pollution, air quality, visibility, all very important things there. And that's one of the reasons that learning this kind of material is important, because any fire managers out there would really need to know, like, if they're doing a prescribed fire, how much smoke it's going to produce, the impacts that could have on communities downwind. So let's just, without further ado, just dive into the material. The effects on soil can be either beneficial or detrimental. The burning away of vegetation and organic matter can enhance nutrient availability, but it can also lead to erosion as hillsides are no longer held in place. So this is one of those cases where wildfire is not just all bad news. It can increase nutrient availability. So now you can think about that. If fire comes through, you have a lot of ash on the landscape now. That ash has some nutrients in it. Plants are going to be able to use that. Same thing happens with nitrogen. If you have a lot of fire exclusion in an area, it can become nitrogen limiting, meaning a lot of the nitrogen's already been kind of taken up into the plant structures, so then they don't have as much nitrogen still in the soil. So if fire comes through, it burns those plants. You do end up losing some of the nitrogen to the atmosphere, which you could view as a bad thing for that individual ecosystem, but some of that nitrogen does find its way back into the soil, and then it's available to plants again. So that's some good news there. Where most of the bad news comes in has to do with erosion. and that's really tied to soil structure. So this was actually one part of the textbook I was a little confused by, because at first it was saying after a fire, your soil becomes coarser, meaning finer particles kind of conglomerate together and become larger particles because the fire is able to fuse clay together. But then it goes on to talk about how most of the time, actually, a fire, you get a finer soil structure. And the reason for that is because the fire can kill a lot of the microorganisms and the fungi that are usually aggregating those soil particles together and even intertwining those soil particles together. And you could think of why that is important. Like the next rain comes, and if your soil is not all aggregated and intertwined together, it's much easier for that rain to just pick up those fine particles and carry them away. So that leads to some more erosion. But then also, just the fact that it's not as many of those large particles, there's not going to be as much porosity and infiltration. So I just threw some big words at you right there. So just think about, like, if you had a bucket with some big rocks in it, and then you poured water on it, the water would be able to fill up that bucket pretty easily because you'd have a lot of space in between those rocks. But if you had a bucket of densely compact clay, and then you pour that cup of water on it, it might be seeping so slowly into that clay that you might have an inch of water on top before it actually finds its way in. So fire comes through, kills the microorganisms, kills the fungi, so they're not making those rocks in the bucket. It's more of the clay in the bucket. So then there's less infiltration, which means when the rain comes, a lot more of that water is just going to flow along the surface and take the particles with it, meaning more erosion. So what's also going to impact how many of those microorganisms are killed, the fungi is killed, some of the roots are killed, seeds are killed, it's going to have to do with your soil temperature. And this one is where it's actually pretty counterintuitive. You would think, okay, huge wildfire, massive flames rushing through very quickly, that's going to burn up the soil. But it's actually the low intensity, slow moving fires that heat up your soil the most. And that kind of makes sense because soil is a very poor conductor. So if a fire goes through very quickly, it's not going to be able to reach down throughout the soil that much. It's not going to have much time to heat up. Versus if you have one of those slow moving fires, even if it's not very intense, that's going to be able to heat it up more. But at the end of the day, soil is still a fairly poor conductor, and it's going to be also dependent on how much moisture is in your soil. That's also important because if you have a lot of moisture, the fire is going to have to evaporate that moisture out of the soil before it can heat up that soil too much and then kill the microorganisms, the fungi, the roots, the seeds, all the important stuff. And then just one last thing about the soil section of the textbook that I thought was just kind of an interesting thing is after a fire, you might have a lot of black ash on the soil, and it also might have cleared out a lot of the trees, so there's less shading. So you're going to be able to get more sunlight coming in. More of that heat is going to be absorbed by the black surface, and then that's going to lead to a higher soil temperature, which would lead to more evaporation, which would lead to lower soil moisture. So then less moisture available for plants to be able to use. And it's, again, because of that black ash is able to absorb heat more easily. Just thought that was kind of interesting, but now let's go on to the water section. Erosion can also be accelerated after fires because the soil becomes more water repellent. With less water infiltration, you end up with more overland flow. This can impact water quantity and quality as both flow rates and sedimentation increase. So it's an interesting concept that after a wildfire, the soil becomes more water repellent. Now you might be wondering why that happens, but it kind of makes sense if you think about some of the waxy leaves that you might see in shrubs or trees. And some of that wax, when it's burnt, it would go into the air and then it would find its way into the soils. And some of that, what's called a hydrophobic compound, could then condense onto the soil particles. And it's easier for it to condense onto the larger soil particles than the small ones just because of surface area. We won't get all into that just right now. Just think about how leaves can be water repellent. Those compounds in the leaf that make a water repellent can go into the air and then condense onto the soil and then that makes the soil water repellent. Now, it's mostly when the soil is dry. After a rain event, it's usually going to wash that hydrophobic compound off of the soil. But before it does, that soil is going to be more repellent, so the water isn't going to infiltrate as much. So that means you're going to end up with more overland flow on top of some of the other reasons that we previously discussed. And then there's also some other reasons that you'd end up with more overland flow. Litter and duff, you think of that as like a lot of leaf layers down in the soil that would be able to absorb a lot of the water. It's almost like a sponge. If that burns up in a fire, it's almost like you just lost your giant sponge on top of the soil. So then that's also not going to be able to soak up as much water. Same is true with shrubs. Usually actually stop about, I think it's 11% of rain from getting down to the surface. Trees can stop as much as like 25% from getting down to the surface. So if the shrubs and the trees burn out, then the shrubs and the trees aren't catching that rain, kind of blocking it from getting to the ground, and then more water finds its way to the ground. And then on top of that, if you don't have shrubs and trees, you're going to have less transpiration, which is the water going out of the soil, out of the plants into the air. So then that's more moisture that's just going to be in the soil, makes it closer to being saturated, and then also just more water on that landscape, which could turn into overland flow. So that was a lot of different ways of saying that after a fire, you're going to end up with more water rushing on the surface than actually seeping in for those reasons and the ones discussed in the soil section. So what that means is you're going to end up with more erosion because the faster water is rushing on the surface, the more it's going to be able to pick up some of that soil, some of those rocks, and bring it down into streams. And then that's going to impact the stream flow and the quality of the water as well. So maybe after a normal rainstorm, your stream is still relatively clear, but if you have a wildfire, then it's going to lead to all that overland flow. It brings all the sediment with it, and then all of a sudden your stream is very muddy and almost sooty. And that can be maybe good if it brings some nutrients down to places downstream that need the nutrients. But it can also actually increase your flood risk, not only because there's more water and it's coming faster than it otherwise would have been if it was getting blocked by trees and absorbed in soil and the litter and duff. So you not only have more water, but then if you're also depositing more sediment downstream, then that's going to kind of take up some of the space that water would be able to go in. So it just makes it easier for it to flood. Hopefully that part makes sense. If not, you can read the textbook yourself. I'm going to go on to the air section right now. And even if you don't live in California, you've probably seen the impact fire can have on air quality as smoke is transported downwind. This can affect the health and well-being of both human and biological communities. So when it comes to wildfire smoke, it might actually be the part of wildfire that impacts the largest amount of people in terms of air quality. We'll get into that in just a moment, but first we could just think about what is wildfire smoke. So when you have shrubs and trees and grass on a landscape and it engages in combustion, that particulate matter goes up into the atmosphere. And the reason it goes up is because as it combusts, there's a lot of heat generated, and then that heat heats up the air, which makes it less dense, which makes it more buoyant, which makes it rise. And as that air rises, it takes some of that particulate matter with it. And then if you have winds, it's going to carry that particulate matter elsewhere, and then you end up with poor air quality on the East Coast because of the bad wildfires that we have in California. And that might be one of the big things people think back to is back in 2020 when the entire state was covered in smoke. And it looked pretty ominous out there. I believe September 9th was that day when there was just that orange glow over, especially like San Francisco. I saw some pretty crazy photos coming out of there. But it's not just ominous, something scary to look at. It's actually pretty unhealthy as well. Within that wildfire smoke, you have all sorts of pollutants. You have carbon monoxide, you have VOCs, particulate matter. So that's unhealthy to breathe. It can also have carbon dioxide and methane, which are greenhouse gases, which if a lot of that is released, then it can make things warmer, which makes the fuels drier, which makes wildfire more likely, which makes more smoke being produced, which creates a positive feedback loop. So that's some of the bad parts of wildfire smoke. And just kind of zeroing in on one especially bad part is if you're in the bottom of a valley, you've probably noticed that your air quality can get especially bad because overnight the hill slopes cool down and then that cold air gets more dense and then it sinks down to the valley bottom. So then you get a layer of cold air below warm air, and that cold air is more dense. So it's almost like your atmosphere is just stable. It's not moving around a lot. And you get what's called an inversion, where you have warm air above your cold air. Usually the atmosphere gets colder as you go up. But this is like your salad dressing that's settled out into all its different layers. It's not moving around a lot. So then that means your smoke is just going to sit in that valley. And in some cases that can actually be better for the people in that valley. When the sun comes through, starts heating up the valley bottom, you start getting that buoyancy, the rising air, you get some of that smoke lifting out of there, and then winds blowing that smoke downwind. Obviously not good for the communities downwind, but good for the community that was just trapped in that inversion. So that's some of the bad things. One other bad thing that I almost wasn't going to say it because it kind of contradicts something we were talking about earlier, but we're talking about how you can have soils that are nitrogen limited, and then fires can actually help it because it makes some nitrogen more available to the soil. But you also don't want too much nitrogen. And if you have a lot of smoke depositing nitrogen in the soils, it can actually lead to so much nitrogen that it makes it a lot easier for invasive species to come in. So that's more of the negatives, but I think people probably aren't as worried about too much nitrogen in the soils as they are about just breathing in that poor air quality, or pour all the smoke and particulate matter that's in the atmosphere. But as always, I like to end on a positive note, and it's not always just bad news. Chaparral, my favorite ecosystem, actually has a lot of plants where the smoke kind of triggers their seeds to germinate because it would make those seeds think that a lot of the competition's been cleared out by a wildfire, so then it'd be a good time to germinate and kind of start its life cycle, more nutrients, more water available for that little seedling. So I think that's kind of cool. I've also seen it a number of times on wildfires where I'm forecasting in the morning and maybe there is a smoke inversion, but you're thinking, oh, it's probably going to lift out, the smoke's going to blow out, and then it's going to be 95 degrees, winds 25 miles per hour, relative humidity 15%. Fire is going to grow 10,000 acres today. It's going to be a bad day of wildfire. But then the smoke is so dense that there's not enough heating to actually break through that inversion. So then it ends up being 65 degrees. And then because you're not heating up as much, your relative humidity is a lot higher. There's a lot more moisture in the air. And then you also don't end up with big temperature gradients. So then the winds aren't as strong. And then instead of burning 10,000 acres, it ends up being a very minimal wildfire day. So sometimes smoke can be a good thing. Obviously, sometimes it can be a bad thing. I think what's important is just learning as much about it as we possibly can. That's why I'm going through this textbook, because think about on a prescribed fire, they could do it on a day where it's not going to produce nearly as much smoke as if some wildfire just came through that area, especially if the fuels hadn't just been accumulating for a long period of time. And then they do the prescribed fire on a day where the winds blow the smoke away from a community. And then they can just factor in all these different things that we've talked about throughout the course of this video and much more that I still have to learn about. And I will keep going through this textbook. If you want to learn more as well, you can come along for the ride, and thanks for watching.